Hi guys, welcome back to my channel. So I came across this really good data science project, and it is for employee attrition prediction. So let's go through the business problem statement. Employee attrition is a critical issue faced by organizations, leading to increased recruitment costs, loss of knowledge, and decreased productivity. Understanding the factors that contribute to employee attrition and being able to predict which employees are at risk of leaving is vital for implementing proactive retention strategies. The goal of this project is to develop a predictive model that accurately identifies employees who are likely to leave the company. The model will enable the HR department to take timely actions to improve employee satisfaction and reduce attrition rates, ultimately leading to a more stable and productive workforce. Okay, so we are having two data sets here, HR attrition data and HR new data. So let's look at both of the data sets. Both Pandas as PD. So df1 is equals to PD dot read underscore CSV. Okay, so we have employee ID, employee number, gender, education, educational field, job role, department, age group, work location, attrition date, environment satisfaction, attribute, attrition count, job involvement, job satisfaction, monthly income, person salary hike, performance rating, placeholder relationship, satisfaction, work-life balance. Okay. Now let's look at the second data set. What does it have? Okay, so DF2. Okay, DF2 dot head. Let's see what we have here. So okay, so employee ID and employee number are same. Okay, so employee ID and employee number is the primary in both of the tables. So last evaluation, number of project, average monthly hours, work accident, promotion last 5 years. Okay. All right. So since as I see that there's a common table, employee number and employee ID. So we will merge both of these table using this primary key. So merging both data sets. Okay, now let's run this df dot head. Cool. So these are merged now, and we can check with this as well. All right. Okay, so there are multiple columns with same type of data, and so many of these are irrelevant as well as per our goals. Let's like dynamic date, and the commons are, for example, the attrition count, attrition one, attrition label. So like these. So let's do the exploratory data analysis now. Let's check the target variable first. Okay, so 237 has left the company and 1233 are still working. Okay. All right. So Now understand this data with individual columns now. Okay. 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 Let's see. So work location, department, and education. So majority of the employees are working in Bangalore location, then Mumbai, then Delhi, and so on. And most of them work in R&D department, then sales, then HR, and most of them have the bachelor's degree. Okay. Okay. So now let's check with respect to the job role. Okay, so the highest one in sales executive, then research scientist, then laboratory technician. Okay. Okay, now let's check this one. Okay, so age, the monthly income, work-life balance, and job satisfaction. Okay. Okay, so now we'll check these categories and numerical values with respect to the attrition. Okay. Okay, so work location. So the highest attrition is in Bangalore, then Mumbai, then Delhi, and with respect to department, the highest one is in R&D. Okay. And in education, the highest one is the ones with the bachelor's degree. Okay. Okay, so the highest attrition is with again sales, then research, then laboratory technician. Okay. Oh, sorry, my bad. The highest attrition is with laboratory technician, then sales executive, then research scientists. Okay. All right, so now let's build up some box plots to check. Okay. Okay, so this is age versus attrition. Monthly income versus attrition. Okay. And job satisfaction. Work-life balance versus attrition. Okay, and we do see outliers in monthly income. Let's check for them. Okay. Okay, let's do the data preprocessing now. Just give me a quick moment. Okay, and then text. Let's check for missing values. Okay, and now let's pick up the relevant columns which are necessary for our model. Okay, now let's check our data frame. Okay, so check our data frame now. Okay, so we have now this is our data frame which we will be working on. Let's drop the missing values. And now let's do the one hot encoding of our categorical values. Let's check our data frame now. Oops, sorry. Okay, so these are in Boolean. Okay, and let's convert the yes and no and attrition column to 0 and 1 in binary. Okay, now let's check the data types. How are they looking now? Okay, so we have no object. Cool. Let's once check the scale of our DF data frame. Okay, so there is a huge difference as I'm seeing it because 1470 and so minimum and maximum is 1 and this is 0. Okay, 18 and 60. Okay, so we need to bring all of these into a single scale, to a common scale. There are huge values. So let's say, because as I'm seeing it here, monthly income, the minimum is 1000 and the maximum is somewhere around 20,000. So we need to bring all of these into a single scale, a common scale. Alright, so we'd be using a standard scaler. And let's build our model now. Let's train our model. Let's train the model now. Okay. We'll be using random forest. Let's evaluate our model now. Okay, 372, 20. So we have a precision of 92 and 95. Okay. Okay, so and accuracy is somewhere around 95%. And this is a confusion matrix. Okay. Okay, so let's export our model now. Okay, so model has been exported. Now let's try to use our model for prediction with some new data. This is first time for me as well. Okay. Okay, so loading the model, giving it some new data. Converting it into a data frame. Let's check. Okay. Okay, now let's do the prediction. Okay, so let's save it into a new column. Now let's check. Okay, so all of them are gonna leave. Okay. Alright guys, thank you very much for watching.